traditional relational databases, they store your information in it, and it's kind of dumb. You request information, you query it, and it comes back to you. I said, what if I could infuse the database with a self-learning system that basically acts like a virus that infects the database to learn interconnections within the data structure that exists within the database and get better, smarter, and so on. This video tries to explain that concept.
Okay, think about this for a second. What if your database wasn't just a dumb storage container? What if it was an active partner that learned from every single thing you asked it? Today, we're going to look at a new piece of tech that's doing exactly that, and it's completely changing the game for AI. Let's get into it.
No, really, let that sink in. Every single time you search for something, you're not just getting an answer. You're actually teaching the system how to give you a better answer the next time. That's the huge idea we're going to unpack today. All right, so first, a quick primer. The engine behind pretty much all modern AI is something called a vector database. These things are amazing. They let us search for meaning, for context, not just simple keywords. They take all this complicated stuff, like sentences or pictures, and they turn them into a string of numbers. We call them embeddings, so a computer can finally understand how they all relate.
But, and this is a big but, as incredible as they are, these traditional vector databases, they have a massive fundamental flaw.
So here's the deal. They're basically a one-way street. You ask a question, you get an answer. End of story. The database itself doesn't change. It doesn't get smarter. It's like having a brilliant librarian who can find any book instantly, but never learns which topics are most popular or how different sections of the library connect. It's powerful, for sure, but totally passive. Which of course brings us to the star of today's explainer, RuVector. This thing was built from the ground up to fix that exact problem.
And there it is. That's the whole pitch in just 6 words. This isn't just about storing and finding information anymore. It's about a system that actively gets better and better every single time you use it.
Now, to really wrap your head around just how ambitious this is, check out this analogy. They're basically saying it's a Swiss Army knife for AI data. It's trying to combine the absolute best parts of all these different specialized tools, all rolled into one powerful package.
So let's break that down, right? You get the lightning-fast search of something like Pinecone. Then, you get the power to understand these deep, complex relationships like you would with a graph database like Neo4j. On top of that, it has the learning engine of PyTorch baked right in, so it can improve itself. And the whole thing is built to be super reliable, scalable, and easy to work with. I mean, that is a massive combination of features. All right, so the big question is, how does it actually learn? I mean, this isn't just some marketing fluff, right? Nope. There's a core piece of tech in here that makes it all possible, and it works by adding one absolutely crucial step to the search process. And this slide right here shows you everything. On the left, you've got the old way. Query goes in, results come out. Simple. But on the right, RuVector slips in this critical new stage, a graph neural network, or GNN layer.
I take the core part of the database, I plug it, I pull it out using an extension. Right, and then my extension goes in and basically kind of weaves its way through the different parts of the information you have, both in a vector and in the traditional data, and then it learns. So let's say you're creating a trading application and you're feeding it all your trades. It would look at that information and understand what the interconnected relationships are in a kind of causal effect, what causes it, and what the benefits or predicting what might happen with it. So it's like putting the inner workings of like a LLM and a graph-based neural network directly in the database itself. I did that as a Rust-based compilation, so it's really, really, really fast. So within that structure, each of the decisions are happening in under 1 millisecond or in microseconds, and then making these little kind of mathematical predictions and trying to determine what the most logical way to go from the broader information. Think of it like if you were thinking the multiverse, it's the area outside of the universe, the vector, right? It's the latent space, the higher dimensions. Now the reality in that scenario would be the graph structure that sits within. That, which is crazy as part of the story, uses something called a hyperbole, hyperbole, I think is what it's called. And that's basically where traditional vectors are flat planes of information. Think of it like a sheet. The hyperbole, they're hyperbolic, allows you to sort of have it like a sphere that ever expands in every which direction with no sort of degradation in the information. Where a flat sheet, kind of like looking at a flat sheet, what you see far away is kind of blurry, and what's close looks like in focus. That creates a problem. This solves that, makes it work faster, 8 times faster.
This little layer sits right between the initial search and the final results, and trust me, that's where all the magic happens.
So what's this GNN layer actually doing? Well, first, it grabs your query and the first batch of results. Then, using this really cool technique called attention, it figures out which of those results are most important to each other and to your original question. And here's the key part. It then actually updates the numerical representations, the embeddings themselves, based on what it just learned. So, over time, the paths that get used most often get stronger, making future searches way faster and a whole lot more accurate.
And what I really like about this is it's kind of like, you know, when you learn to play an instrument and you do the same chord over and over, or you learn any kind of instrument, it's a lot of muscle memory. And what's happening in that process is you're training the parts of your brain, right, to do those things and understand and instinctively know it kind of really fast, right? So what I'm doing in this scenario is I'm allowing the system, which has attention applied to it, to understand the paths it needs to take to get to the right response for different problems really, really, really fast. Much the same way when you think, you can sort of remember that you have to play that chord a certain way, or move your fingers for a saxophone a certain way, or other things that involve sort of a muscle memory. I'm doing exactly the same thing here. Now, what's really interesting is I've applied that using the concepts of a spiking neural network. So rather than trying to do everything all at once, I'm pointing just at the thing I need to do very, very surgically. And the craziest part is it works really well. And I'll show you guys some examples here in a minute.
But here's the thing. RuVector isn't just a one-trick pony with this learning stuff. All that intelligence is backed up by some seriously impressive high-octane performance.
Okay, get a load of this number. 61 microseconds. That's insanely fast for search latency. It means that all that extra learning and processing, it doesn't slow things down. You get the smarts and the speed.
And it's not just fast, it's crazy efficient. It can automatically shrink the data it's holding by up to 32 times. Now, if you're running AI at any kind of scale, that kind of savings on memory is, frankly, a huge deal. It can save a ton of money.
That uses something called episodic memory. So each part of the memory is either compressed or not compressed based on what it needs to remember. So you know when you go to sleep at night and all the things you did that day are basically moving from your sort of front of your brain to the back in kind of an archival state. So I thought, what if I created a multi-step mechanism that compresses that information based on how relevant and new it is? So the stuff that's happening right now is completely uncompressed and clear and clean. And then I take that information that might be an hour old or a day old, and I compress it more and more as the further back it goes. Eventually, all the information is compressed to a point of like 32x. So it takes tons of information and it remembers the interconnected nature of how to find and what the important parts of that information is, and then allows it to be compressed.
This table just lays it all out, plain and simple. You put it side by side with a major player in the space, and the differences are just stark. Self-learning with GNN? Check. Graph queries? Check. Built-in reliability and that slick auto-compression? Check, check. These are real game-changing differentiators. So, how does that compression work? Well, it's really clever. Think of it just like your computer's memory. The data you use all the time, the hot data, it stays right there in full precision, ready to go at top speed. But the stuff you haven't touched in a while, the database automatically moves it to colder tiers, where it gets compressed down. The best part? You don't have to do anything. It just works. Okay, so we've got this super smart, super fast, super efficient database. So what? I mean, what does this actually let you build in the real world? Why should you care? First up, a huge one, RAG. That stands for Retrieval Augmented Generation, and it's the secret sauce that lets large language models pull in fresh, up-to-date information to answer your questions. Bottom line, a smarter retrieval system means a smarter AI. And look how simple it can be. This little bit of code is basically just asking RuVector, hey, give me the 5 most relevant things you know about this question. And because RuVector is always learning, the context it sends back gets better and better over time. That means the AI's answers become way more accurate and useful. All right, next up, recommendation engines. We're talking about the systems that power Netflix or Amazon. This is where combining that speedy vector search with those deep graph queries becomes an absolute superpower. Now, this query might look a little complex, but what it's doing is amazing. It's not just saying, hey, people who bought this also bought that. It's saying, show me what this specific user has looked at. Now go find me other products that are deeply and fundamentally similar to those items. You start uncovering these hidden connections that simpler systems would totally miss, and that leads to mind-blowingly good recommendations.
So, when you step back and you look at the whole picture, what are we really seeing here? This is way more than just a new database.
What we're talking about is a genuine paradigm shift. We are moving away from this old idea of databases as passive filing cabinets. We're moving toward a future where our data infrastructure is an active, dynamic, learning partner in building better AI.
And that really leaves us with one final crucial question to think about. As AI gets woven into the fabric of everything we do, we have to ask ourselves, is our data just sitting there gathering dust, or is it actively working to get smarter? Projects like RuVector are making it pretty clear that the future belongs to the learners.
This is a cool tool, right? I just fed it all my code, said, give me something I can explain tonight to the crew so they don't think I'm a maniac, which I don't blame you for thinking.
And graphics as well?
Did all the
Graphics.
I'll show you how I made it. Yeah, I'll show you how I made it. And it does different styles. You can customize it for whatever. It does PDFs like presentations or videos with the voice and everything.
How long did it take
Well, this took about 5 minutes.
with the voice?
Yeah, I'll show you how to do it. It's crazy.
But you had
I had the code. I sent it to my GitHub. Like this is just this. I said, tell me about my GitHub. And it cranked out like a professional presentation with a few little quirks, but